Welcome to Chemistry with Dr. Z. In this video, I'm going to talk to you about the redox reaction. Redox reaction are basically oxidation and reduction reactions. So, as a general definition, you can talk about or define oxidation and reduction in terms of gaining and losing oxygen. So gaining of oxygen is defined as oxidation, and any reaction that has a substance that gained oxygen, this substance will be oxidized. So oxidation is gain of oxygen. For example, when you have metals, can be oxidized to make metal oxide. So when metals react with oxygen, like magnesium with oxygen, that will give you magnesium oxide. Now the magnesium has gained oxygen and magnesium was oxidized in this reaction. On the other hand, the loss of oxygen will be reduction reaction. So we have reduction, it's the loss of oxygen. So for example, when copper oxides react with carbon, it will give copper metal and carbon dioxide. Now the copper has lost an oxygen and then the copper was reduced. So this is a reduction reaction. So why do we call them redox? Because redox mean oxidation and reduction at the same time. Actually, redox reaction refers to any reaction that has oxidation and reduction. And oxidation and reduction take place at the same time. So when one atom is oxidized, another will be reduced in the exact same reaction. So both will take place in the same reaction. So this is why it's called a redox. Redox can be defined in terms of gaining and losing oxygen, as we said before, but the wider definition is actually the loss and gain of electrons, not the loss and gain of oxygen. So oxidation is actually loss of electrons and reduction is gain of electrons. So let's have some examples to see what is oxidized and what is reduced in a specific redox reaction. So the first redox reaction or the first example we are going to talk about is the reaction of metals with acid. So we learned that metals will react with acids to give metal salts and hydrogen will be produced. So when a metal reacts with an acid, this is an example of a redox reaction. Some example of this is iron will react with hydrogen chloride as an acid that will give you iron, chloride, and hydrogen. So this is an example of redox reaction because actually iron was oxidized in this reaction because iron lost two electrons. Iron, we have iron here as a metal, and then it lost two electrons to give you iron 2 plus, which is the ion. So ion 2 plus now lost the iron lost two electrons to give you the iron 2 plus, so it was oxidized. Hydrogen on the other hand, it gained electrons, so we have two hydrogen ions here from hydrogen chloride, and then the hydrogen gained two electrons to give you the hydrogen a gas, or to give you the element hydrogen, which is not which is neutral, which doesn't have any charge, which means the hydrogen plus gained electron. So we have two hydrogens and the two hydrogen ions gained two electrons to give you the hydrogen element. So iron was oxidized by the hydrogen and the hydrogen was reduced by the iron. So you have one substance that will be oxidized and the other will be reduced, and this takes place in the same reaction. So this is a type of redox reaction. So how can we write the equation for this type of redox reaction, or for this reaction? There is something called the ionic equation and the half ionic equation. So half ionic equation is the equation where we only show one substance at a time. So we only show the oxidation or the reduction. So the half ionic equation for iron, we said iron was oxidized, so iron metal will give you the ion, and it lost two electrons, plus two electrons. The other half equation is the hydrogen. So we have two hydrogen ions, hydrogen plus, gained two electrons to give you the hydrogen to give you the hydrogen element which doesn't have any charge. The ionic equation will be the total of these two equations. So when you add these two equations, the electrons on both sides will cancel each other out, and the ionic equation will be iron plus two hydrogen ions will give you the ion 2 plus the hydrogen. Notice that in the ionic equation, we only show the ions that are actually reacting, so the ones that are oxidized and reduced here, but the chloride is not shown in this equation at all because the chloride hasn't changed at all. So it's not shown in the ionic equation. The chloride ion is called the spectator ion here, and it's not added to the ionic equation. Another example of redox equations or redox reaction is the halogen displacement reaction. So we know that a more reactive halogen will displace the less reactive one from their salts. For example, we know that chlorine will displace bromine or iodine from their salts and to give the chloride salt. An example is a reaction between chlorine and potassium bromide to give you bromine and potassium chloride. So now we know that this is a redox reaction. Can you think about which one has been oxidized, which one has been reduced? So chlorine was reduced. That was reduced as the two chlorine atoms here gained two electrons to give you two chloride ions. So we have two chloride ions, and we started off with the chlorine, which are neutral or don't have any charge. And then the bromide was oxidized because the bromide lost two electrons because we have bromide minus, and the two bromide lost two electrons to give you the bromine. So this is the oxidation. Oxidation and reduction took place at the same time. One is oxidized and the other was reduced, and this is a redox reaction. The half ionic equation, we will write it in the same way. So we have the two bromide will two bromide ions will give you bromine and will lose two electrons. So the two electrons here, this is the oxidation because of the loss of the electrons. And then the chlorine will gain two electrons, and this is reduction to give you the chloride ions. So this is reduction, which is the gaining of electrons. Ionic equation, we have the chlorine plus the two bromide to give you two chloride and the bromine. So again, we added the two half equations together. The two electrons on both sides have cancelled each other out, and then we ended up only writing the ions that took part in the reaction. Again, the potassium was not written in the ionic equation because potassium here is the spectator ion. It didn't change at all in this reaction. The third example of the redox reaction is the metal displacement reaction. So we learned about the reactivity series, and the more reactive metals will displace the less reactive ones from their salts. So if we have something like iron, when iron react with copper sulfate, one of the salts of copper, and we know that iron is above copper in the reactivity series, so iron is more reactive than copper. So when iron react with copper sulfate, it will displace the copper to give the salt of the iron, which is iron sulfate, and then you will get the copper metal. This is another type of redox reaction. We can see that iron was oxidized as it lost two electrons to give you the iron ion, which is iron 2 plus. While the copper was reduced as it gained two electrons because it changed from copper 2 plus as an ion to give you the copper atom, which is not charged. Writing the half ionic equation, starting off with the oxidation reaction, which is the iron. So iron will be oxidized to give the iron 2 plus, and two electrons will be lost. The reduction reaction, we have the copper 2 plus that's going to gain two electrons to give you the copper element or the copper metal, which is not charged. And the ionic equation, adding these two together, the two electrons on both sides will cancel each other out, and then we end up with the iron plus copper 2 plus to give you the iron 2 plus and the copper. Again, the sulfate ion was not written in the ionic